As we're beginning our study of kinematics, we want to start with speed. The word kinematics means the study of motion. So what is speed? Speed is the rate at which something can move. How do we measure speed? Well, the simple answer to that question is we don't do it directly. We measure two other quantities that allow us to determine or calculate the speed. We don't do it directly. We calculate it from other quantities, other measured quantities. And those quantities are distance and time. Even a speedometer on a car is not measuring speed directly. It's actually measuring the distance and the time, and the speed is being calculated. So when it comes to speed, we, before taking physics, just use the word speed, but it turns out that there are a whole bunch of different kinds of speed or types of speed. In the simplest form, the average speed over an interval is always given by this formula. V bar, which means average speed, equals d over t. The distance traveled over the time it was traveled. D in this case means the total distance, and t is the total time. And V bar is the average speed. The bar over any variable means average. And this is a very important equation. It's one of the most powerful ones in all of physics. Because over an interval, this equation is always true. It always works over an interval. So that's the first kind of speed, the average speed. In general, the average speed is the total distance over the total time for a given interval. But we also have instantaneous speed. Instantaneous speed is the speed at a particular moment in time. When one is driving a car and you look at your speedometer, that speed is the instantaneous speed. It is the speed at a particular instant. Although it's not always true, it suggests change or changing speed. If we are at the toll plaza and we take off with our car, we can see the instantaneous speed changing on the speedometer. However, if we're traveling on the highway, we may be in cruise control, and the instantaneous speed doesn't change at all. It stays at a constant 55 miles per hour that we set the cruise control. Initial speed. Initial speed is the speed at the beginning of the interval. We could say at the start of the interval. And the final speed is the speed at the end of the interval. Now each of these has a particular letter that gets used for them, or a variable. Each of these is a quantity, and each of these quantities has a variable. Instantaneous speed always has the variable v. It is just simply lowercase v. Initial speed actually has three different variables that mean the same thing. The I stands for initial, but we could also call it V0, where the 0 is time 0, meaning the beginning. In another set of equations, we refer to this as simply U. So all three of these mean the same thing, the initial speed. The final speed, it turns out, is also just represented by v most of the time. It's the speed at a particular instant. It is also referred to as vf. So we could have an initial velocity, v0, and at some point in time, at the end of an interval, we want to know the speed, the instantaneous speed. Well, that would be the final speed, the speed at the end of an interval. Yet another way to describe speed is constant. Constant just simply means unchanging. We could think of this as being like cruise control. And then, of course, we have changing speed, which is where we are using the brakes or pressing the gas pedal. Changing speed. The speed could be increasing or decreasing. Often the first question we want to ask ourselves when considering a situation in physics is whether the speed is constant or it's changing. We can have an instantaneous speed that is constant. We're traveling down the highway on cruise control. Or we could have an instantaneous speed that is changing. We just take off at a stoplight and press the gas pedal. We can also have an initial speed that is constant. Imagine one is driving down the highway in your car and one receives a phone call. The initial speed at the beginning of that phone call remains the same. So the initial speed and the final speed and the average speed all mean the same thing in that case. There is another formula for average speed, and this one is special. This formula can only be used when the acceleration, which we will speak more about later, is constant. So what is this formula for average speed? This average speed formula is V bar equals Vf plus V0 over 2. We could, of course, also write this as V plus U over 2. But this formula only works when acceleration is constant. Now let's apply